Good morning. If you're watching this, it's assumed I should congratulate you and that you've gotten through all of the must-do transformations, and we have one last transformation that is a should-do. So let's go through that now. On your should-do notes, we have learned that a negative in front of a function reflects it over the x-axis. So if you give yourself any function called f of x, say, I don't know, let's do like a line with a fun curve at the end. When I see a negative, if this is f of x, when I see a negative in front of that, we reflect it over our x-axis. So this part will reflect down here, the curved part will reflect down there. We've seen lots of that. Well, what do you suppose will reflect a function over the y-axis? And what happens there is if I put a negative inside the parentheses, negative x, let's say, inside the parentheses, we will get a reflection over y. So f of x, to reflect it over the y-axis, is f of negative x. So a negative x within the parentheses reflects over y. What I'm going to do next is show you how it works with two different problems, and then the last two problems you can do on your own to help you study for any should-do bonus style questions on your test. So here's what happens. Let's say we have y equals the square root of negative x plus 1. First thing as always we want to do is recognize the parent graph, and in this case it's y equals the square root of x. You can graph that quickly now. 0, 0 is my anchor. 1, 1. Square root of 4 is 2. Square root of 9 is 3. So there's my parent square root of x graph. The key difference in reflecting over y is we need to rename the stuff inside that's been negated. And we do that by factoring. And we factor out the negative 1. So that's a key critical step. We have to factor out negative 1. We promised you in the beginning of the year that you'll see factoring in almost every chapter, if not every chapter, and here's where it appears in this one. So I start with y equals the square root of negative x plus 1. I need to factor out that negative 1. Negative x divided by negative 1 is positive x. Positive 1 divided by negative 1 is minus 1. So that is how we rename, and that's the critical step. That's really the only difference in reflecting over a y-axis. So now it's math is consistent, what we've always seen. We look for transformations. Within my parentheses, my grouping symbol, I have x minus 1. Well, that's a translation to the right 1 unit. So I can take all the points on my first child, or parent, sorry, and translate them to the right 1 unit, which means my anchor point also moves right 1 unit. Now because I don't have different colors, I'm using different symbols. The last step is this new negative underneath my parent graph attached to the x. That's my reflection over the y-axis. So I take that most recent graph and I reflect it over the y-axis. Just like reflecting over the x-axis, you go the same distance on the opposite side of the y-axis. So we move over here. This is 1 away. We go 1 away on the opposite side of y. This point is 2 away. Go 2 away. 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. And this point is 10 away. Move it 10 away. And here is my final graph. Its anchor point is negative 1, 0. And it's then that last child reflected over the y-axis. That's pretty cool. Let's do some more. And again on the graph, f of x equals 3 to the negative x plus 2. The parent graph is f of x equals 3 to the x. It says it's graphed for you. I didn't do that. Math is consistent, so it's going to work just like 2 to the x. It's going to look very much like 2 to the x, but our base is 3. So we're going to think numbers 3 to the in our head and plot those points. So let's see. 3 to the 0. Any number to the 0 is 1. So on any of these parent graphs, 2 to the x, 3 to the x, 5 to the x, 1/2 to the x, we'll always have a 0, 1 anchor point. Any number to the 0 power is 1. Now, let's think about other numbers to plug in. 3 to the first is 3. 1, 3 is a point on this parent graph. 3 squared is 9. 2, 9 is a point on the parent graph. 3 to the negative 1 is 1 over 3 to the first, or 1/3. 3 to the negative 2 is 1 over 3 squared, or 1/9. It's going to be pretty hard to draw. So again, we can see that we're getting super duper close to 0, but never getting there. So our x-axis is an asymptote, a line that a graph approaches but never touches. So there's the parent graph that actually was not graphed for you, but we just did that together. So just like the previous equation, we need to rename the child because I have a negative up there attached to the x plus 2, and that entire exponent behaves as grouping symbols, parentheses. So I'm going to rename that child as f of x equals 3 to the negative, factored out, x minus 2. And now again I can see my transformations. Minus 2 in parentheses, I translate right 2 units. Negative out front, I reflect over the y-axis, and we can graph them now. So I'm going to try to switch colors here. Translation right 2 units, take each point on the parent and go right 2. So my anchor point moves to 2, 1. And there is the translation to the right 2 units, color-coded. Then I need to take that red graph and reflect it over the x-axis. So, I'll take a black pen, or sorry, the y-axis, and reflect all of those red points over the y-axis. So this point is 1, 2, 3, 4 away from y. I go 4 away to the other side. This point, 3 away, 3 away. This point, 2 away, 2 away. This point, 1 away, 1 away. Kind of matches over there. So my final graph, f of x equals 3 to the negative x plus 2, looks like that. And there you go. You now know all of your transformations. Reflection over the y-axis being our last one. Notice if you choose to try 3 and 4 as should-do problems to help you with bonuses on the test, notice that they're both square root parents. And think about why. If we took, it's just an extra little note, and I'll let you go. If we took that parent and reflected it over y, we wouldn't see anything. It's symmetric with respect to the y-axis. If we took y equals the absolute value of x and reflected it over y, same deal. So we're not going to reflect those over y because it's silly, it's redundant. When we have a graph that's symmetric with respect to the y-axis, it would be silly for us to reflect it over y. So really, the only parent graphs that we'll deal with right now to reflect over y will be our square root, which we've seen, comes over there. Our x cubed, which some of you thought reflecting over x was reflecting over y, but we actually could do both. Again, it ends up getting a little redundant because it has points of symmetry. And any of our exponential graphs, 2 to the x, 3 to the x, and things like that. So, point is this. If you have symmetry in your parent graph with respect to the y-axis, we won't be reflecting over y. It's redundant. If we don't, then we can practice with it. So the last 2 problems for you to try on your own, 3 and 4, are both parents of square root because they're not symmetric with respect to the y-axis, so it makes sense to be able to do some reflecting. And that is it. Congratulations, you have gone through all the videos for Unit 3. I will see you in a few days when we start Unit 4 quadratics. Have a great weekend.